Okay, we're going to try introduction to the sine curve now. So now we're going to go ahead and try to take this concept. So remember, sine is the y value of the point on the unit circle. This is the unit circle. There's positive x-axis. The theta measures the angle, and I got degrees and radians, although I want you to get used to the radians. The red represents the length of that opposite side of the triangle. So we can see when it's down here on the x-axis, it hasn't gone anywhere, so the value is going to be 0. When we go to the first angle on the unit circle, pi over 6, we remember that, we only had 3 numbers, and there are the 3, the height of this triangle, the height of this triangle, the height of this triangle, and they were a half, square root of 2 over 2, and square root of 3 over 2. And those are the same numbers, square root of 3 over 2, square root of 2 over 2, a half, and then we start doing the negatives. So there's lots of symmetry in this graph. So at pi over 6, we can hit the first number, which is a half, which is 0.5. Fine. The next one was square root of 2 over 2. That is approximately equal to 0.71, because remember, we're going to be trying to graph this. And then we get to square root of 3 over 2, which is about 0.87. And when we get up to the top of the curve up here, we're at 1. All right. Looking at this, now we plot those. There's 0, 0. That's where we started. Now we come down here. The first one we hit was pi over 6. What's pi over 6? Well, pi is about 3, and divided by 6 is about a half. It's a little bit more than a half. So a little bit more than a half and up a half. So that's about a 45-degree angle right there. Pi over 4. Thank you. Oh, and there is pi over 4. When I'm at pi over 4, I'm up to that 0.71, the square root of 2 over 2. And then when I'm going to go to the next one, that is my pi over 3. And at pi over 3, we're going to be at 0.86, square root of 3 over 2. And then finally at pi over 2, we've reached the top of the circle. We're up to 1. Now remember, we go back down the circle. So now I'm going to be another pi over 6 this way. Well, I was at pi over 2, and pi over 2 plus pi over 6 ends up being 4 pi over 6, reduces down to 2 pi over 3. So at 2 pi over 3, we're at the square root of 3 over 2, 0.86. This one is pi over 4 plus pi over 2. That's 3 pi over 4. We're back down to 0.71. The ones with the 4 as the denominator, they're always the square root of 2 over 2 or 0.71. I'm going to clue you in on that right now. And here's my 5 pi over 6, which is back to a half. And then I'm going to get up to pi, and I hit back on the x-axis. So I'm back to 0. My y is back to 0. Then we keep going around the circle. There is pi over 6 plus pi, which ends up being 7 pi over 6. That's a half. And then this one is going to be 5 pi over 4, which is 0.71 again. That one is going to be 7 pi over 6. No, sorry, 4 pi over 3. Yeah, 4 pi over 3 is that square root of 3 over 2, negative square root of 3 over 2. And when I get over here to 3 pi over 2, I'm down to negative 1. And then we're going to start going back up. And there's the rest of the sine curve. Put in the line through it. You can see it looks like that. It looks like a wave. We come back. We went once around the circle. That's called one period. All right. And then the one thing I want to say before we're done is there's my sine curve again. Now, I didn't do cosine, but cosine is very much related to sine. You can see that's the blue one is cosine. It looks exactly like the purple one, except for it's been moved back that far. Well, how far is that? That's pi over 2. So if you remember from our transformations, that the cosine is the same as the sine of its complement, because A and B are complementary. They're alpha and beta, 2 new Greek letters for you. Those two things are complementary. And so sine of this angle, opposite over hypotenuse, A over C, is the same as cosine of this angle, which is adjacent over hypotenuse. So that's why there's a resemblance between those two curves.